In this section, we're going to look at how we can divide by a third. We also call that rationalising the denominator. And the reason why we call it rationalising the denominator is something we will look at in a few moments. First of all, we're going to look at an example. So if we start off with 3 over root 2. Now that means 3 divided by root 2. We can't just simplify that like we've done with multiplying or adding in an algebraic fashion. Here we have to do something different. Also, if you think, what does 3 divided by root 2 actually mean? Well, that means how many root 2's go into 3? But we know root 2 is irrational, and root 2 is approximately 1.41, and it goes on forever and ever and ever. So we can't actually say how many 1.41, blah, 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 all these digits that go on forever and ever, how many times does that go into 3? We can't do that. Just get rid of that. Okay. What we can do, however, is we use a method where we multiply top and bottom, so the numerator and the denominator, by the third that's on our original denominator. So here we're going to times by root 2 over root 2. So what we're actually doing is times top and bottom by the third on the denominator. Let's see what we get. So we're doing 3 times root 2 over root 2 times root 2, which we know simplifies to 3 root 2 over square root of 2 times 2, which is 3 root 2 over square root of 4, which gives us 3 root 2 over 2. And what we've actually done there is written another expression for 3 over root 2. And now, the reason we are calling it rationalising the denominator, hopefully you can see, is because our denominator is now rational. It started off being irrational and it's now rational. So that's why it's called rationalising the denominator. A couple of other points to note. These two expressions are equal because all we have done is multiplied by 1. And if you multiply by 1, you are keeping the expression the same. So that is really 1. In this slide, we're going to look at more examples when we are dividing by a third or rationalising the denominator. So we'll start off with another example, say 10 root 2 over root 5. So we're going, how many times does root 5 go into 10 root 2? And we can't work that out. So again, what we do, we multiply numerator and denominator. We multiply top and bottom by root 5 over root 5. What we're doing, we're multiplying by the third that was on our original denominator. Remember, root 5 over root 5 is actually 1, so we're not changing anything. So now, 10 root 2 times root 5 over root 5 times root 5. When we're multiplying by thirds, a third by a third, we do the coefficients, which is just 10 in this case, and root 2 times root 5, so root 2 times root 5, all over root 5 times root 5. You don't need to actually use that step, that's just an extra step I'm putting in there. Okay. We can simplify that to get 10 root 10 over root 25. We know that root 25 simplifies to 5. And then now, because we've got 10 root 10 over 5, we can actually cancel the 10 and 5 and make it 2 and 1. So our final answer is 2 root 10. Right, we're going to look at 2 more examples, and hopefully you'll have got the hang of it, where we're just dividing by just a third on the bottom. Remember, we're rationalising the denominator because the denominator becomes irrational. It's not a third anymore. So our example that we're going to look at 5 over 2 root 3. So what we're doing 5 divided by 2 root 3. So what we want to do, we're going to times top and bottom only by the third. Okay. If we times by 2, we can times by 2 root 3, okay, but all that means is we have to simplify further later, and I'll show you that in a minute. So we just times by root 3 over root 3. Remember, this is really 1. So then we get 5 root 3 over 2. Root 3 times root 3 is just 3. So we're left with 5 root 3 over 6, which is all nicely simplified for us. What would have happened if I times by 2 root 3? So let's have a look and see. So we had 5 over 2 root 3, and we're going to times by 2 root 3 over 2 root 3. So we do 5 times 2 root 3, so 5 times 2 is 10, and then we have root 3. And the denominator, we've got 2 times 2, which is 4, and root 3 times root 3, which is 3. That leaves us with 10 root 3 over 12. We can now simplify 10 and 12, divide both of them by 2 to get 5 over 6, which is 5 root 3 over 6. So we get the same answer, but we just took more steps. So to me, that way is just a bit of a waste of time for us. So we won't do it like that. You can see that it gives us the right answer, but it just takes longer.